welcome back to my channel. Today we will continue with chapter 3, electric current and direct current circuit. In this video, we will continue with subtopic 3.6, Kirchhoff's law. Example 11. For the circuit in the figure above, determine the current and its direction in the circuit. Okay, so from this diagram, from these circuits, we notice that there is no directions of the current. Okay, so you can draw any directions. Okay, so for example, let's say I draw the current is in anti-clockwise. Okay, so meaning that the whole circuit here, the current will flow in anti-clockwise. Okay, and if you want to determine the directions of the current and the value of the current, here we must use Kirchhoff's second law. Okay, because Kirchhoff's first law, we know that I for the whole circuit is actually same I because R is connected in series. So we cannot use Kirchhoff's first law to solve these questions. Okay, so we must use Kirchhoff's second law. Okay, so when you want to use Kirchhoff's second law means that it is actually, we need to refer to a loop rules. Okay, we can call it as loop rules. Okay, meaning that the total potential at the end will equal to 0. Okay, so for example, let's say I start from point A. Okay, so when you start from point A, at the end you must go back to point A. Okay, so this is our starting point. Okay, and also before you determine the value of the EMF and also the current, okay, we must draw a loop first. Okay, so the important thing is you must draw a loop. Okay, and the directions of the loop you can determine by yourself. Okay, so usually the directions of the loop, we will follow the directions of the battery, come out from terminal positive of the battery. Okay, so for example, for this case, I prefer the loop of the directions of the loop is also anti-clockwise. Okay, so now we start. Okay, so we start from point A. Point A, the loop is going downward. Directions of the loop is going downward. Okay, so first we are going to passing through. The first one is the 15 volt. Okay, so the directions of the loop, okay, and is come out from the terminal positive. So we write it as positive 15. Okay, and also there is an internal resistor 4 ohm. So internal resistor 4 ohm, the directions of the current. Okay, the directions of the current is going downward and the directions of the loop also going downward. So both of them are similar. So we substitute in positive because they are same direction. And when the current passing through the resistor, the internal resistor, okay, the energy is dissipated. So we must substitute negative for I, indicate that the energy is dissipated. Okay, so we continue with 15.1 ohm. Okay, so 15.1 ohm, the directions of the current and the directions of the loop are same. Okay, so we substitute positive because of same direction. And when the current is passing through, okay, when the current is passing through the resistor, okay, there is a energy dissipated. So we must substitute negative 15.1 I. Okay, so we'll continue. Okay, we'll continue to 6.22 ohm. So we are passing through the 6.22 ohm. Okay, so again, the directions of the current, okay, the directions of the current is similar with the directions of the loop. Okay, so they are similar. Okay, same direction. So we substitute in positive because of same direction. And when the current is passing through the resistor 6.22, so it is actually negative 6.22 I. Okay, because energy dissipated inside the resistor. Okay, after that we continue to move and then we will passing through a battery. So the first one battery is 11.5. Okay, so it refer back to the loop. Okay, the directions of the loop is actually to the right, and it's actually come out from the terminal positive, enter negative and then come out from terminal positive. So EMF is positive 11.5 is potential rise. And then remember, there's also an internal resistor of 2 ohm. Okay, so when it refers to the resistor, we must refer back to the directions of the current that flowing through the resistor and also the directions of the loop. So the directions of the current is to the left, the directions of the loop also to the left. Okay, so it's positive because of same direction. And then because this is a resistor, so we must minus because of energy is dissipated. Okay, so it's 2I. And then we continue to move to 8.5 ohm. So again, 8.5 ohm, the directions of the current and also the directions of the loop are similar. Okay, so we substitute positive because of same direction, and negative 8.5 I because of energy dissipated. Okay, so at the end, it will come back to 0.8. So it's equals to 0. So we need to rearrange back. Okay, so when you rearrange back, you will find that actually the value for I is equal to 0.74 ampere. Okay, so this is the value for the current that flowing through this circuit. Okay, and the directions, again, the directions, how can we determine? Okay, so if the answer that you get is positive, meaning that the directions of the diagram that you draw just now is correct. Okay, so if we refer back to the diagram, the current directions of the current is actually anti-clockwise. Okay, so our answer is anti-clockwise. Okay, because the value that we get is actually positive. Positive means that based on the diagram, the directions of the current is correct. Okay, if let's say the answer that you get is negative, if let's say you get negative, meaning that the directions from the diagram, okay, directions of the current from the diagram is actually in opposite direction. Okay, so if let's say you get negative, meaning that it's actually flow in clockwise. Okay, so now we get positive, meaning that based on the diagram, the directions of the current is correct. Okay, next we will go to example 12. Okay, example 12 here, we have a two loop here. Okay, so this one a little bit complicated. So the question asks us to determine the value of I1, I2, and also I3. Okay, so let's say this is I3. Okay, let's say this is I3. Okay, so here we have two junctions, junction A and junction B. Okay, here we have two junctions, junction A and also junction B. Okay, so usually the current will flow from one junction and then enter to another junction. So for example, I1, okay, I1, it will flow out from B, okay, from B. So this is I1, and then passing through 12 ohm and then passing through 3.9 ohm. So this is I1, okay. So if you use a highlighter, this yellow color is actually I1, okay, I1 that passing through. Okay, and then we have I2. Okay, so I2 again come out from junction B, okay, and then it will go passing through 9 ohm, and then it will again passing through 6.7 ohm resistor, and then enter to junction A. Okay, okay, then we also have I3. So I3 come out from junction A, and then it will passing through 1.2 ohm resistor and then enter to junction B. Okay, so we can use Kirchhoff's first law. Okay, so Kirchhoff's first law state that I that enter the junction is equal to I come out from the junction. Okay, so if we refer to junction A, okay, you can take junction A or junction B. Okay, both also you will get the same equation. So for example, let's say I take junction A. So I that enter is actually I1 and also I2. Okay, I that out from the junction A is I3. So this is my first equations. Okay, but this I1, I2, I3 are unknown, so we cannot get any information. Okay, so we must use Kirchhoff's second law, where Kirchhoff's second law, okay, where V total is equal to 0. Okay, so before you want to use Kirchhoff's second law, it's actually loop rules. We must follow the loop rules where we need to draw first. Okay, so for example, let's say for the first loop, okay, okay, I prefer clockwise because I want to come out from terminal positive of the battery. So this one I will choose clockwise, okay, for loop 1. Okay, and then loop 2, okay, so loop 2 I will prefer in anti-clockwise because I prefer my directions of the loop come out from terminal positive. Okay, okay, so now we go to loop 1 first, the first loop. So loop 1, again, let's say I start from point B. Let's say I start from point B. Okay, you can start at any point as long as the starting point, okay, is you come back to the starting point. Okay, so let's say I start from point B, and then my directions of the loop, okay, is going from point B to the left. Okay, point B to the left. Okay, so let's say at point B to the left. Okay, so the directions of the current and directions of the loop are similar. Okay, so we should substitute positive because they are similar. And because it is a resistor, so we must minus 9.8, and then current that passing through 9.8 is actually I1. Okay. Okay, next we continue to move. Okay, so we'll move upward, and then we will passing through a 12 volt. Okay, EMF is actually a 12 volt, so it's actually potential rise because the directions of the loop is come out from terminal positive. Okay, it's come out from terminal positive, so we substitute in positive 12. Okay, and then we continue to move, and then we will passing through 3.9 ohm. So 3.9 ohm, the directions of the current is similar with the directions of the loop. Okay, if you refer back, the black color one is the directions of the current, and the red color is the directions of the loop. So both of them are similar, so I substitute positive because they are same direction. Because the current passing through 3.9, so energy dissipated, so we must substitute negative 3.9, and current passing through is I1. Okay, after that we continue to move. Okay, and then we were passing through the 1.2 ohm resistor. Okay, so the directions of the current still the same. Okay, the loop and the directions of the current I3 still the same, so it's positive because same direction, and negative 1.2 I3 because of energy dissipated. And we come back to point B. So when we come back to point B, it's actually equals to 0. Okay, so this is the equation, so we need to rearrange back. Okay, we need to rearrange back one equation where we will get 13.7 I1 plus 1.2 I3 equals to 12. So this is our second equation. Okay, our third equation, it comes from loop 2. Okay, so it refers to loop 2. Okay, we start from, let's say we start from point B. So when you start from point B, you must follow the loop direction. Let's say this is my loop, I start from point B. So I will, first one, I will passing through the 9 volt. Okay, 9 volt battery. And then my loop, directions of my loop is actually come out from terminal positive. Okay, terminal positive here. So the first equation is positive 9 volt potential rise. And then I will passing through the 6.7 ohm. Okay, so the directions of the loop and the directions of the current are similar, so I substitute positive because of same direction, and minus 6.7 I2 because I2 that passing through 6.7 ohm resistor. Okay, and then we continue, so we are going down and then passing through 1.2 ohm. Okay, so again the directions of the loop is going downward, and the directions of the current I3 also going downward. So substitute positive because of same direction, and negative 1.2 I3 because energy dissipated, and at the end we come back to point B, so it's equals to 0. Okay, so if you rearrange back the equations, we will get the equations is equals to 6.7 I2 plus 1.2 I3 equals to 9. So this is our third equation. Okay, now we have 3 equations. So what should we do is you must take out your calculator. Okay, calculator, and then you go to mode. Okay, after that from mode, then you go to equations, and then you choose unknown. Okay, so unknown, we have 2 and 3. Okay, so actually here we have 3 unknown. We have I1, I2, I3, so you press 3. Okay, so you take out your calculator, press mode. Okay, after press mode, find equations. So for equations, you press unknown. Okay, after that you choose 3. Okay, so from there, so you must arrange your equations in this term. A I1 plus B I2 plus C I3 equals to D. Okay, so the first equation we need to rearrange. Okay, in 1 I1 plus 1 I2 minus 1 I3 equals to 0. Okay, and the second equation we must arrange it 13.7 I1 plus 0 I2 plus 1.2 I3 equals to 12. And the third equations we need to arrange back, where we will get 0 I1 plus 6.7 I2 plus 1.2 I3 equals to 9. Okay, so if you press calculator, okay, the first value A1, you substitute 1. Okay, and then B1, you substitute 1. C1, you substitute -1. And then D1, you substitute 0. Okay, next it will comes to A2. A2 is 13.7. B2 is 0. C2 is 1.2. D2 is 12. Okay, so we continue with A3. A3 meaning that the third equations is 0. B3 is 6.7. C3 is 1.2. D3 is 9. Okay, so after you press calculator, the answer that we will get for I1 is equals to 0.72 ampere. I2 is 1.03 ampere, and I3 is equals to 1.75 ampere. Okay, so this is a value for I1, I2, and also I3. Okay, next we'll continue with questions B. The potential difference across the 6.7 ohm resistor. So we must refer back 6.7 ohm resistor is actually, okay, this one. Okay, 6.7. So V is equals to IR, okay, meaning that our V is equals to I2 and the resistor is 6.7. So we substitute here. Okay, V is equals to I2R because I2 that we're passing through the resistor of 6.7 ohm. Okay, so I2 here is 1.03 and the resistor is 6.7 ohm. Okay, so the potential difference across 6.7 ohm is actually 6.9 volt. Okay, next we continue with find the potential difference between point A and also point B. Okay, so we want to find the potential difference between point A and also point B. Okay, so we'll refer back here. Okay, from point A to point B, actually we have a different path. Okay, so okay, let's say I clean up this one first. Okay, I show you. Okay, either A to B, you can use this path. This is the shortest one. Okay, where from point A we goes to point B. Okay, so for example, let's say I want to find the potential difference across point A to point B. So I will start from point A where VA. Okay, I start from point VA and then I will go down and then passing through 1.2 ohm resistor. Okay, so the directions of the current is going downward and the directions of the loop that I draw red color is also going downward. So it's actually positive because they are same direction. And then we must substitute -1.2 I3. Okay, why negative? Because energy dissipated when the current passing through the resistor. And then I will come back to point B. So it's actually equals to VB. Okay, so VA minus VB is equals to 1.2 I3, where I3 is equals to this one, 1.75. So I substitute here 1.75. Therefore, I will get 2.1 volt. Okay, so this is the shortest one. Okay, if you don't want to use this this path, you also can use the other path. For example, let's say you want to start from start from A and then passing through 3.9 and then go to 12 volt and then go back to B. Okay, if you want to use the blue color path also can. So let's say, for example, let's say we use blue color path where the current is actually flowing in clockwise. Okay, but when you want to find A to B, our loop here, it will go in the other way, in anti-clockwise direction. Okay, so if let's say we want to use blue color path, meaning that we start from A, okay, and then I will go through 3.9. So because the directions of the current and the directions of the loop is opposite, so I substitute negative and then substitute -3.9 I1. Okay, so the first negative is because of opposite direction. The second negative is because of the energy dissipated inside the resistor when the current passing through. Okay, and then we will continue to move. Okay, we'll continue to move and then we'll come to a battery. So if you refer here, the directions of the loop here is actually come out from terminal negative. Okay, so we substitute inside -12 volt because of potential drop. Okay. And then we'll continue to move, and then we will passing through 9.8 ohm. So the directions of the loop is to the right. However, the directions of the current I1 is to the left. So it's opposite direction. So we must substitute negative because of opposite direction, and negative 9.8 I1 because of they are a potential drop due to the energy dissipated. And then I come back to point B. So it's equals to VB. Okay, so if you arrange back VA minus VB, okay, you will get 12 minus 9.8 I minus 3.9 I. Okay, so if you substitute in I1, okay, this is I1, I1, we will get also 2.1 volt. Okay, you will get the same answer. Okay, and after that, actually, you also can try this one. You also can try this part where we can start from 6.7 passing through 9 volt and then come back to point B. Okay, so you will get the same answer, 2.1 volt also. Okay, so that's all for this subtopic. We will continue with 3.7 electrical energy and power. Okay, see you on next videos. Bye.